Substitution of halogens by cyano group. So cyano group can replace the halogens such as chlorine, bromine, and iodine. We have taken the example of methyl halide, where X is any halide among these chlorine, bromine, and iodine. And when it is subjected to react with two different reagents such as potassium cyanide and silver cyanide, then we get some kind of different products in both cases. In the first case, where the reagent is potassium cyanide, we get the product as cyanide. And in second case, the reagent used is silver cyanide and the product obtained is isocyanide. As we know in chemistry as well in pharmaceutical chemistry, these reactions have the major role and used to get the products which contain cyanide as well. These cyanides can be converted into some other functional groups such as carboxylic acid and amides as well into primary amines, and isocyanides also can be converted into secondary amines. So there are different areas where these cyanides or isocyanides can be used further for the medicinal chemistry purpose as well, to make the compounds which may be anti-cancer agents, anti-malarial, and anti-diabetics. So these reactions have major roles. So our question is, why potassium cyanide provides cyanide as major product and silver cyanide is furnishing isocyanide as major product. So what is the major difference between these two reactions? So look at the example number 1. In this, ethyl bromide is subjected to react with alcoholic potassium cyanide and the product obtained is cyanide. Basically, potassium cyanide. So it is ionic in nature. The bond between this carbon and potassium is ionic in nature. So it is present in the form of ion. So here it is used as alcoholic KCN. Alcoholic means C2H5OH is present in this reaction in the presence of heat, and the reagent is KCN. When it is KCN is dissolved in ethanol, it forms ions K positive plus Cn negative. You can see the negative charge is residing on this carbon. When the negative charge is present on this carbon will act as nucleophile. Clear? So we know nucleophile will attack on the species which is electron deficient in nature. So in ethyl bromide, this carbon is partially positively charged due to the presence of leaving group, as bromine is an electron withdrawing group. So it will make this carbon little bit electron deficient, due to which this carbon acquires partial positive charge. And the next is how the nucleophile attacks on this alkyl halide. You can take the example like CH3, CH2, Br. So basically, this carbon will attack on the carbon of ethyl bromide, and the bromide ion will be act as here leaving group, and it will form cyanide and potassium bromide as byproduct. So this is our major product. So the reason here is the potassium cyanide is ionic in nature. Due to its ionic nature, the negative charge resides on the carbon. Thus, the carbon is acting as nucleophile. Yeah. Yeah. So there are some another example, like example number 2. In this, the reactant is methyl iodide. Similarly, it is also allowed to react with alcoholic KCN in the presence of heat. Then again, you get the product methyl cyanide plus byproduct potassium iodide. So you can do some conversion reaction in which there there is need of increasing the carbon number. In reactant, there is only one carbon, and in the product, we are getting the product in which there are two carbons. So by this, you can form the homologous series. Ascending homologous series. Ascending homologous series means the increasing the length of carbon chain by one carbon atom at a time. So this is more clear from example number 2 and 1 how we can obtain the ascending homologous series. So it can be obtained by the use of potassium cyanide. So I have already told you cyanides are very useful and can further used to convert into some other functional group like carboxylic acid, CONS2, primary amines, which have major role in the area of medicinal chemistry to synthesize effective drugs. Yeah. Okay, so these are certain examples in which I have shown how these cyanides are converted into different functional group. The example number 3, in the presence of concentrated HCl and water, it forms amide group CONH2, where the water molecules attack on this carbon and there is electromagnetic shift on it and it is converted into CONH2. The fourth example in which we have been using two molecules of water when the the acid is in diluted form. Two molecule of water means the acid is more in diluted form. Here in the third one we are using concentrated HCl where only one molecule of water is used. When you are using two molecules of water, then you will get carboxylic acid as a product with the byproduct ammonia. So actually what is the mechanism here? This one molecule of water attack on carbon and there will be electromagnetic shift toward nitrogen, then it will form OH NH2. Again, when the second molecule will attack, then there is breakage of this bond. Here is NH instead of NH2, then you will get CH3COH NH2, then OH. Then this hydrogen will be abstracted and here the leaving group will be NH2 negative. It will leave as NH3 as it is more clear from the second example. Yeah. So this is a mechanism. So you don't need to focus on this mechanism. The journal I told you how we can get amides and carboxylic acids from cyanide. Similarly, the another reaction is Mendius reduction, in which the cyanide is subjected to undergo reduction reaction where these double or triple bonds get reduced to form primary amines. This carbon is converted to CH2 and nitrogen gets converted to NH2. And the functional group here is amine. So this is your primary amine. Okay. The next is reaction with silver cyanide. Yeah. Silver cyanide, the bond between the silver and carbon is covalent in nature. Covalent in nature due to the large size of the silver, it forms covalent bond with CN group. So here the carbon do not have any kind of negative charge. So carbon will not act as nucleophile in this case. In this case, the nitrogen bears a one lone pair of electron. Due to its lone pair of electron, it will act as nucleophile. So nitrogen will donate its electron to the electron deficient species such as methyl or alkyl bromide or iodide. So look at the example. In this, the reactant is methyl iodide and the reagent is silver cyanide in the presence of alcohol, and similar conditions are used as we used in the previous case in case of potassium cyanide, but the product you get is isocyanide. Isocyanide. When there is formation of a bond between carbon and carbon of cyanide group, then we term it as cyanide. When there is formation of a bond between carbon and nitrogen, and the nitrogen comes from the cyanide group like NC, yeah, then we call it as isocyanide. So this is the difference between the nomenclature. When the bond is through the carbon of cyanide group, then it is called as cyanide group. You can normally call it as cyano group. CN group only named as cyano group. When the carbon forms a bond with carbon, it is known as cyanide. When the nitrogen forms the bond with carbon, it is called as isocyanide. So that's why I'm calling here it as cyanide. But the how it forms a bond with this methyl iodide, as this methyl group is electron deficient in nature due to the electronegative nature of this iodine group, and the nitrogen from from silver cyanide will donate its electron to methyl group, and the I negative will act as the leaving group. There is formation of a coordinate bond in which nitrogen has donated its electron to the methyl group. So coordinate group is represented with this arrow like this. Yes. It can also be represented as CH3 and positive, negative, because this is the another format to represent the coordinate bond when the nitrogen is losing its electron and the carbon is gaining electron. So these both are same structures, but the way of representation is different. This is a coordinate bond. Coordinate bond is also type of a covalent bond, but in covalent bond, there is sharing of electrons, but in coordinate bond, the electrons are donated by one atom, but shared by both atoms. So this is the difference between a covalent bond and coordinate bond. Yeah. So alkyl cyanides further, these also can undergo reduction reaction when subjected to undergo reduction reaction. It will furnish secondary amines. So you can get secondary amines from isocyanides. Clear? So why in case of silver cyanide, the product is isocyanide? It is due to the covalent nature of these compounds. So the metal wholly affects the fate of the reaction, as this is a resonating structure of cyanide where the this is structure number one and the structure number two. In structure number one, there are three bonds between carbon and nitrogen, and in two, there are only two bonds between carbon and nitrogen. When the electrons are transferred toward this nitrogen, the carbon gets positively charged. When the carbon acquires positively charged, these both get neutralized. Thus, now here carbon is neutral in structure number two. And as the nitrogen is gaining electrons, then it will acquire a negative charge on it. So these both are resonating structure. The further one can be converted into two, and we can also convert the second into one. That's why we call it resonating structure. So we can also conclude that the cyanide group act as ambidentate nucleophile. Ambidentate nucleophile means those nucleophiles which have more than one site through which the reaction can occur. As the in case of cyano group, the reaction can be occur through this carbon as well as through the nitrogen. So it has two sites. That's why it is called as ambidentate nucleophile. Clear? So in summary, the alcoholic KCN gives the cyanide as major product, and the alcoholic AgCN furnishes isocyanides as major product. It is due to, in first case, the ionic nature of KCN compound, and in second compound, the AgCN is covalent in nature. So this is a basic difference between these two reagents, which led to formation of two different products. So thank you for watching my video. Please share and subscribe my channel. And if you have any query, then you can ask me in the comment section. Thank you.